Ach, lassen Sie uns einfach loslegen. Schönen guten Morgen in die Runde. Mein Name ist Christina Sehe von der Boston. Ich grüße Sie sehr herzlich zum heutigen Webinar mit der Micron. Unser heutiges Thema ist AI oder KI, Rechenzentren, ist ein bisschen gemischt heute zu DRAM 6400 und alles, was so im Bereich AI Richtung Rechenzentrum notwendig ist, um einfach leistungsfähig zu sein. Meine heutige Referentin, ich freue mich sehr, ist Esther Spanier von der Micron. Hier auch schon ein Bild. Und die Esther Spanier ist Director im Enterprise Channel Business Development bei der Micron Technology. Und ich, wie gesagt, heute in der Moderation. Ich freue mich sehr. Das Webinar heute wird in Englisch abgehalten, deswegen switchen wir auch gleich ins Englische über und noch vorab einige Informationen. Die Präsentation, die Sie heute vor sich sehen, bekommen Sie im Anschluss als Download zugeschickt. Auch zeichnen wir diese Sitzung, dieses Webinar auf, um Ihnen einfach im Nachgang auch noch die Gelegenheit zu geben, reinzuhören oder es an Kollegen weiterzugeben. Und bei Fragen natürlich Fragen, wenn Sie während der Präsentation oder des Vortrags Fragen haben, schreiben Sie die gerne in den Chat. Wir beantworten sie am Ende. Jetzt I'll switch over to English. Good morning, Esther. Thank you for coming and for the webinar. And I hand over to you today. Thank you.
Thank you, Christina. And good morning, everybody on the call. It is, as always, a pleasure to be with everybody, and I hope you all have a wonderful day, and we'll walk away today with a little bit more knowledge about some of the latest trends in both DRAM and SSD technology when it comes to the future of our data centers. Before we get started, so the agenda that we have here are basically I will give you a few updates on the on our company, what's happening with our company, and then we'll dive right into some of the trends in both the SSD market as well as the DRAM market. But before we get started, I want you to be aware that we are going to hand out three crucial SSDs, the external SSD that you can connect to your laptop. There will be a raffle at the end of this session, so please stay all the way till the end, and we will raffle off three names of people that have attended this webinar. So with that, let's get started with the Micron updates. I'll just wanted to share a few highlights of where our company is and what we are doing recently. So first of all, we shared our quarterly revenue for the last quarter. We have these kind of strange fiscal quarters, which are different than the calendar quarters, but our Q1 results are basically the months that cover September, October, November of last year. We had a record quarter, $8.7 billion, of which roughly 70% came from DRAM products and 26% came from NAND products. It was the first quarter that we surpassed more than 50% of our revenue came from data center products, and that is something that if you look historically at our company is quite a big shift. We used to be much more a consumer and embedded company, so automotive, mobile phones, and consumer products. In the last 5 years, we've been focusing more and more on getting our product portfolio aligned with servers and data centers, and that's really starting to show in our latest quarterly results. We also this was our largest quarter in history. $8.7 billion. And so we are at the moment doing really well after what was a challenging, I would say, year and a half in the overall semiconductor market. We also have been working hard on making sure that our future, is secured. We are investing a lot of money in, R&D and manufacturing. We pledged to invest more than $150 billion in the next 10 years to ensure that our roadmap and our competitiveness will still be there, in the next 10, 20, 30 years. One of the things that we are doing as part of that $150 billion investment is building new manufacturing facilities in the United States. We're building one new fab in our headquarters in Boise, Idaho. The image that you see here is actually a real image of the construction that is going on over there right now. And then we are building an additional, what we call mega fab in the state of New York. Those will be eventually 4 fabs over the course of the next decade that we will be building. And then another facility we have in Manassas, Virginia, is going to be kind of modernized such that we can also start manufacturing our latest technology over there. This used to be more of a legacy fab. So all in all, lots of investments are made into new manufacturing facilities. You see that is done in the United States, which is, not that typical. Many companies, right? Historically, we've all been in the Far East. One of the things that we learned during the Corona time is that we need to be, spreading our business risk and not only being dependent upon, what's happening in a particular region. And hence, we decided to spread our manufacturing footprint. So that was just a short update onto where we largely as a company stand. I typically don't like to spend that much time on, if you will, the marketing blah blah, since you all came here probably to learn more about what is happening in the SSD space and in the DRAM space from a technology perspective. So let's get started with that. First of all, of course, when we're talking about the trends in the industry, it's all about AI. We all know that, this is where the growth is. This is where, the money is being made. When we're looking at the overall, portion of the server market that continues AI-based servers, that is by far the fastest growing portion in the market. And so what you will see is that the majority of the products that vendors are bringing into the market will be optimized for the demands of an AI server. And so when we're looking at, the technology that we're putting into a server and then eventually into a data center, there's really 3 key things that, when you're looking at storage and also at memory, the 3 key things that we need to focus on is, of course, the highest performance that we can possibly get so that we can, run these AI models as fast as possible. We see certainly a large trend to higher and higher capacities, 60 terabyte. There's even some, some discussion already of 120 terabytes hitting the market. And so, the drive for higher and higher capacity so that we can store larger and larger data sets that eventually then will be used for our AI models, will continue. But then last but not least is the energy efficiency. As we're, growing our data center footprints and the capabilities that these data centers need to provide, they're going to be more and more energy hungry. And so doing more with less is going to be super critical, and so the energy efficiency of the products that are going into these data centers will become a very key deciding factor moving forward. So one of the things what Micron is doing when we are designing our product, we're really trying to be best in class when it comes to these products. Sorry, to these metrics, I apologize. So one of the things, of course, when we're looking at that, higher and higher performance that the market is demanding is the transition to the next generation of PCIe Gen, we're moving right now from Gen 4 to Gen 5. And the primary reason that we're doing that is because the performance that we can get with a Gen 5 SSD is going to be higher than Gen 4. And so with the push to more and more bandwidth, more and more performance, it is clear that the market is now very quickly going to transition to Gen 5 based products. At the same time, we're also starting to see a transition to some newer form factors that started to be introduced, some of them with Gen 4, but with Gen 5, we're starting to see some new form factors. E3 is a new form factor that didn't exist before and will continue to grow in its share. And so I wanted to spend a little bit of time on these new form factors and explain the reasoning why the industry is moving away from the traditional U.2 and U.3 and moving towards these newer form factors, E1 and E3. So when we're looking at the Gen 5, right, we're doubling the performance, but when we're doubling the performance, we're also going to use more power. When you're looking at an SSD design, the power consumption is pretty much directly correlated to the performance. The more flash chips you can write to, or flash die you can write to in parallel, the higher the performance you can get, but that means that you need to provide power to more flash banks, and therefore your power consumption will be higher. Now, the challenge that we saw with some of the older form factors, U.2, U.3, is that there is a limited or maximum power envelope that they can provide based upon the specification. And so the industry had to come out with newer form factors that enabled more power draw, so that we can enable PCIe Gen 5 and eventually even the performance requirements of PCIe Gen 6. So the industry has come out with two new form factors. The E1 form factor has been around for a while. You may even know this long one on the left-hand side as the Intel ruler. This has been a form factor that's been around for a long time. It was specifically designed for some hyperscale customers that had 1U servers. And so it was really tried to optimize the space in that 1U server. It hasn't really become popular so much in kind of smaller data centers. Still the largest user of this form factor is Microsoft Azure. But on the other side, the E3 form factor will become a much more popular form factor and is in essence going to replace the U.2 form factor. So the E3 new form factor, it kind of looks very similar to the U.2 form factor or U.3 that we've used in the past. But you see that it is slightly different. The connector is sticking out, and more importantly, the maximum power envelope of this form factor is substantially higher than the U.2, U.3, and therefore enables for higher performance. So just a little bit more detail on the two form factors. E1.S, what you will see in the industry available is multiple what we call Z heights. Each one of these, you're seeing kind of a side view. They have a larger and larger heat spreader as the performance capabilities of these drives will increase. Micron today has two flavors of this, the 5.9 and the 9.5 millimeter. Again, the majority of the customers that use this are larger hyperscale customers that are utilizing 1U servers. The typical data center that we service through our channel partners are in general more using 2U servers, for which this new E3 form factor is kind of more optimized and replacing the traditional U.2 and U.3. As you can see, it looks very similar, but again, that connector is sticking out. And so what we're seeing is that there's going to be in the market multiple flavors of this E3 form factor with different connectors, PCIe by 4, by 8 and by 16, so that we can have different performance tiers for its use case. At the PCIe by 4 will become what we call our mainstream storage or boot capabilities. PCIe by 8 will become our kind of high-end performance devices, which is where if you look in the market today, the highest performing SSDs in the market that you can find will be a PCIe by 8. And then the PCIe by 16 are not yet available in the market, but eventually you can imagine that this is going to be, very, very high performance used for, GPU acceleration and, super, super intense performance workloads. So when we're looking at kind of the power envelope of all of these different drives, all of these different form factors, you see here that the traditional U.2, U.3 at the top, the maximum power these drives can take is 25 watt. The E3, theoretically, if you look at the E3.L, L stands for long, it can go up to 70 watts. So you can imagine that this drive would be capable of far more performance than our historical or traditional U.2, U.3. My assumption is, and of course this is a new form factor, so we're still in early days and seeing which one of all of these different flavors is going to be most popular. My assumption or my crystal ball will be that the E3.S form factor with 40 watts will become kind of the dominant configuration, and as such that means that we are going to be able to get up to 40 watts in power consumption, which is enabling a much higher performance tier than the traditional U.2 U.3 devices that went up to 25 watt. But that's really the whole purpose of these new form factors, to enable a roadmap, a path to higher performance, and higher performance equals higher power. PCIe Gen 5 will have both U.2 and U.3 support, as well as E3, but once we move to PCIe Gen 6, you will not find U.2 and U.3 in the market anymore. That will be completely gone. So when we're looking kind of at the transitions that we are in the data center, today we're transitioning from Gen 4 to Gen 5. So we will still continue with the U.2 form factor, but we're adding the E3 form factor. And then once we go to Gen 6, we would not be seeing the U.2 form factor anymore. We would only stay with the E1 and the E3 form factor. I see that there is a question in the audience. Or is that not Christina? Am I seeing that? Oh, or you just said that, you just wrote that. Okay. Got it.
Yeah,
Sorry, you
it
wrote.
for me. Yeah,
Okay.
go
All
ahead.
right. No, I
Thank
was
you.
wondering if there was a question that I could answer on the spot. So when we're looking at the Micron products that are available with this new form factor in PCIe Gen 5, we have today a new product family that came out, our 9550. This is our highest performing tier in our product portfolio. And you see that we have here the three form factors, U.2, E1.S, and E3.S available so that we can still service customers that have connectors in their servers that are U.2, but at the same time customers that have already moved on to servers that can utilize the E3 or E1 form factor. When we're looking at the 9550, we are very proud to say that today this is the fastest SSD on the market. And that's something that we don't take lightly. But you will see in a little bit that we have some comparisons around this. Equally important is the energy efficiency. Remember when we started to talk that the data centers, right, are drawing more and more power, and so we have to do with more, and that means that we're trying to create products that are going to do more with less or the same amount of power, so more energy efficient. The drives that we're bringing out into the market, the 9550, are going to go all the way up to 30 terabyte, super high performance, sequential read and write basically are filling the entire PCIe Gen 5 bandwidth with up to 14 gigabytes per second read and 10 gigabytes per second write. And then the random read and random write is just through the roof. There is pretty much not a single drive that you will find in the market that is faster. So this is really a drive that is focused on very, very performance sensitive applications, AI modeling, building of AI, and crunching all that data so that you can build your AI model faster and faster, basically, as you're putting more and more data in there. When we're comparing this drive to some of our direct competitors, we're not alone in this market. But when we say we are the world's fastest data center, we feel very confident that that our claims are right. We are pretty much on all the metrics that you're looking at when it comes to reading and writing to an SSD. We are better than our competition. Sequential write, we're 67% better. You see here random read and write, we're also call it 30 or so percent better than our competition. So we brought a drive to the market that we feel competes with the best, and definitely has its own ground to be proud of. At the same time, we also looked at the how will this do in AI workloads, right? I mean, a synthetic performance benchmark usually is great, but doesn't say much. We actually ran this drive also through a lot of the different AI workloads called, one of them is graph neural network training. We did some medical image training, large language model inference, and the NVIDIA GPU Direct. And without going into too much detail on all of these applications and workloads, what we basically measured is the performance of this drive versus the competition, as well as the energy efficiency. So higher performance is good, and better, lower meaning better energy efficiency is better. And so you see that in all of these graphs, we did substantially better than our direct competitors. So again, a claim on why we feel that we have a very, very solid drive that's capable of a lot. The other thing that I thought was worthy of mentioning is that the 9550, together with one of our other drive that's been in the market for a while, has been, is on the qualification list or the recommended list, what we call RVL for the NVIDIA GB200 platform. And so, any kind of server that will use that GB200 platform, that Grace Blackwell Superchip, the 9550 and the 7550 that we sell are qualified and are working as expected with this platform. Then we're focused so far a lot on performance. Now, at the same time, we're seeing this trend towards higher and higher capacity as well. And so Micron has recently also released a high capacity drive, 60 terabytes, also a PCIe Gen 5. Also, as you can see here, in these three new form factors, the E1, E3, and U.2. And what we really try to do here is optimize, dollar per gigabyte. So we created a drive that is meant to be storing a lot of data. That data, needs to be read fast in order to provide to kind of build your AI model. So it is not a drive that is meant for kind of caching kind of capabilities. It is meant as a drive that you have to store a lot of data that you will then feed into your GPU machine when you're starting to create these AI models. So very, very good read performance, moderate write performance, and moderate endurance, because the intent and the purpose of this drive is to be as cost efficient as possible with this high capacity. Whereas the previous drive that I talked to you about, it was all about optimizing the best read and write performance. This new 6550 is optimized for very good read performance and then for the best cost possible. So when we're looking at this this new drive that we created, two capacities that are available, 30 terabyte and 60 terabyte, in these three new form factors that we've been talking about, E3, U.2, and E1. And when we're looking at the performance numbers, you can see that the read performance is the same as the previous drive that we talked about, the 9550. It basically utilizes the entire PCIe Gen 5 bandwidth, but the write performance and the random read and write performance is lower than the 9550, as again, this drive was optimized for cost and read performance and not optimized for write performance. When we're comparing this drive with some of our competitors in the market, Solidigm, Samsung, Western Digital, we of course are comparing ourselves there on the performance scale, and we're really substantially better than all of these direct competitors when we're looking at all of these different metrics, sequential read, sequential write, random read, and then what we call fill rate, which means that how long does it actually take you to write the entire drive with data till it's completely full. So the faster you can do that, of course, the better it is. So all in all, also here we feel that we've brought to market a very competitive drive that again can compete with the best and actually outperforms them. When we're looking at the energy efficiency, also here, right, this is kind of a recurring theme that we gotta do more with less as we're moving to these new data centers that are going to be so power hungry. And so when we're looking at the energy efficiency, also here we we are really doing a lot better than our competition across all of these different kind of metrics that you're seeing here. Then the other interesting thing that is starting to show up is the E3 form factor. It allows us to actually squeeze more drives into a 2U server. When we had our traditional 2U server and we used U.2 or U.3 drives, we could maximum get 24 drives in there. That was kind of, historically, we were replacing, kind of the traditional hard disk drive slots. And so mechanically, that's kind of what we, have been working with for a long, long time. The E3 form factor allows us to be more efficient in our space and allows us to get up to 40 drives in the same 2U server. So that means that if you were to fill an entire rack with servers that are filled with drives, you can actually get to much higher capacity in the same space. Again, when we're looking at the efficiency, right, do more with less, optimizing your data center space, is going to be critical as we're moving forward in our technology. So that is a nice byproduct from the E3.S form factor that we were able to do compared to U.2. And so the last thing that I kind of want to share with you on the this new 60 terabytes drive, also here we looked at different AI workloads, medical imaging again, checkpointing, deep learning. Also here, of course, we looked at performance, energy efficiency, and across the board, the 6550 really was substantially better than the competition. And again, these are all kind of statements that when we're looking at different classes of drives, what we're really kind of focusing on is the use case of these drives and what we're trying to do with this drive. So performance, of course, is always important, but the performance with the 9550 was the key design factor. The cost for the 6550 was the key design factor, but of course we still need to make sure that we are not forgetting about energy efficiency and the other metrics. Okay, so when we're looking at the entire portfolio of Micron, this is what it looks like today. We have the high performance 9550 that is currently, as I mentioned, the best performing SSD in the market. We have that high capacity NVMe that we're launching in April, the 6550. Of course, we still have a traditional SATA drive for legacy servers, and then our mainstream 7450 and 7500 series for your general purpose server. But today we specifically talked about the 9550 and the 6550, as these are the first two PCIe Gen 5 that we are adding to our portfolio, and that of course is going to be the future of our data centers. Throughout this year, we will add additional PCIe Gen 5 products to our portfolio. All right, so moving on to some of the trends on the DRAM side. Also here, right, the trend is more and bigger. We want more performance, we want higher capacities. And so what are we doing on the DRAM space, in the DRAM space, to enable better and better performance and higher and higher capacity? So more performance really is coming from the fact that we're creating more and more cores per CPU in our servers. But when we have more cores in our CPUs, we need to have more bandwidth to feed those cores. So when we still had our DDR4 3200 speed, and we would have improved, we would have increased the core count at some point, right? These cores would be sitting there without any bandwidth behind them. So the DRAM technology that sits behind these cores needs to keep up with this increased core count and therefore increased bandwidth. And so what we've started to see is with DDR5, we started with 4800 mega transfers per second. We're transitioning now to 5600 mega transfers per second. And recently, the industry is already looking at 6400 mega transfers per second. And so it really is, to alleviate the bandwidth per core challenge, right? More cores, you need more bandwidth, and that means we need to go to higher and higher speeds in our DRAM technology. So 6400 mega transfers per second is the latest and greatest technology that we can find on the DRAM side. So when we're looking at kind of like how the transition is happening at the moment, right? 4800 is still the majority of the demand, but we're starting to see more and more demand for 5600. And with the new 6400 based systems, so AMD Turin and Intel Granite Rapids and Sierra Forest systems that are starting to hit the market, we're starting to see demand for 6400 slowly ramping as of pretty much this quarter. For your information, 4800 speed from Micron will be end of life in July with a last time ship in January of 2026. So we are very quickly going to ramp down the production of our 4800. The 5600 will stay alongside the 6400 in the foreseeable future. But of course, once the 6400 systems are fully deployed in the industry, we will start seeing that transition from 5600 to 6400 happening as well. When we're looking at the availability of the Micron 6400 products, all the standard capacity points, so 16, 32, 64, and 128 gigabyte are available now. We are also bringing out what we call these non-binary capacity points, so 24, 48, and 96 gigabyte. That will be available in April. And then, when we're, arriving in April, if you will, we will have the full portfolio of 6400 based products from the Micron offering. Please note that when you're looking at the pricing today, you will see a difference between 5600 products and 6400 products. There still is a premium on 6400 based products. I expect that to be around for at least 2 quarters before we slowly will start seeing a convergence between the pricing of the 5600 and the 6400. But there is currently about a 10 to 15% premium over 5600 based pricing, again, as we are ramping up this technology. The other new thing that is coming are when we're, there's additional form factors besides the RDIMM form factor. We are also coming out with an ECC CU-DIMM and an ECC SO-DIMM. So these are, kind of different form factors that are used for slightly different use cases. CU-DIMM for high-end desktops, workstations, and networking equipment. CSO-DIMM for small form factor servers, workstations, and network equipment. Now you see that all of a sudden we put this C at the beginning. We used to call these things an ECC U-DIMM, and now we're calling it an ECC CU-DIMM when it's the 6400 based products. The reason for that is that we had to add an additional clock driver, as you can see here on the image, to improve data integrity at these higher speeds. And so somebody in the industry decided that because of that, they're adding that C in front of the word. So it's in essence the same kind of product as you've been, or that's been around for a long time, but because of this additional clock driver, we added that C in front of it. We will have all these new ECC, CU DIMMs and SO DIMMs, sorry, CSO DIMMs available, rolling out in between March and May of this year, as we are ramping up our 6400 based, technology. So overall, when we're looking at the entire DRAM portfolio of Micron, lots of different flavors, from 16 gigabyte all the way up to 128 gigabyte. You see all these different speeds, 4800, 5600, and 6400. As I mentioned, the 4800s are going to go end of life, and then the 6400 will be available now, and then we'll have additional, configurations coming on line in the next few months. And that is kind of the update on, some of the newer products on the DRAM side. I also wanted to share with you a new page that we launched on our website, our partner ODM page, where if you go to this page and you're using any of these ODMs, you can actually see which Micron products are qualified at which server platforms. So if you are using any of these ODM vendors, this is going to be, a great tool for you to look and see, if we have done an official qualification with the product that you are interested in. And with that, I am finished with what I wanted to share with you today. My name is Esther Spanger. If you have any questions, feel free to send me an email. Of course, you can also put a question in the chat right now. And with that, I'm going to give it back to you, Christina.
Thank you so much, Esther, and thank you to all the participants for today's webinar. I hope you had fun and could catch some new information. So let's see what the next webinar will be, and I hope we see you in person first.
Okay.
Next. Yeah, great.
All right.
Thank you so much. Have a nice day, and yeah.
Thank you so much, Christina, and see you in Germany next month.
Great. Thank you.
Thank you. Bye-bye.
Bye.